I thought long and hard about what to say today, and I can make it very short. You are not crazy. Okay, you remember nothing else. This whole symposium about telling you or reassuring you that you're not crazy. So there is something that many of us have been, varying amounts of time, maybe 5 years, 2 years, 6 years, saying, I must be crazy. Because what I'm doing is not working, okay? So it turns out, some of us have gone through that journey as well, and have been bubbling around, and we've been talking to each other, and there's sort of emerges this, what I call industry intuition, around something that we would call knowledge first AI. But actually, I want to tell you a story, okay? I'm going to ask you a question, and the answer must be yes. And if it's not yes, you are indeed crazy. How many people have seen Star Wars? Okay, I see a whole bunch of hands not up. Okay, so I'm here actually to tell you the story of Star Wars. It turns out many of us who give talks and so on are sort of trained in the art of public speaking and so on. Actually, this is one very common theme, and it's used in movies as well. How many people have heard of the hero's journey? Right? Right, Joseph Campbell, PBS and so on. So it turns out many movies follow this basic plot line. There's a regular person, he or she is just minding their own business, right? Just not a hero, just everyday ordinary person. And then some challenge comes, a dragon comes in, or in the case of Peter Parker, he got stung by a spider. And it follows this pattern, and then he or she finds some major weapon. There's a Merlin that comes along and say, I'm going to give you special powers and so on. And then they kill the dragon and so on. So that's the basic plot line of the hero's journey. But it turns out in many of our lives, in our work, we do go through this hero's journey, right? And there's a term, of course, we all know called industrial AI. I actually prefer the industrial AI. When I talk to the average person, they say industrial AI, their eyes roll over. And they say, this has nothing to do with me. But in fact, it is life-critical AI, right? What you see here is the classification by Homeland Security, right? And if you look at the industries that the U.S. considers, life-critical, these are the things we must have. You notice something dominant about this, and it is all physical. For the maybe financial industry, not quite physical, but there's a lot of it that is physical. And there's a reason for that, right? We're still physical beings. We still eat fish. We still drive cars and so on. And so these things really matter. And for the most part, in the US at least, in the last 30, 40 years of globalization, we've kind of outsourced, pushed away a lot of that making of things, right? My friend Mark Andreessen likes to say, software is eating the world. But actually, in the last 5 years, we realized, okay, well, it's not so good to really outsource all of the making, and we got to bring that back. So all of this is critical infrastructure, and many people in this room know that, right? If you walk around in this Silicon Valley bubble, you wouldn't know it, right? Because people, you talk about these things, people go, well, I'm interested in effectively clicking, making people click ads more because that's that's very profitable. So the movie plot here is the sort of the call to action, right? So here is Luke, young Skywalker, right? Suddenly seeing Princess Leia for the first time, and she's calling for help, right? And I want to say this very nicely because I don't want to offend, but in a way you can think of this as answering the question, why did GE fail? Why did IBM, Watson fail? And I say this, I have many friends there, right? Major institutions, very smart people, but was in a way badgered into the wrong approach. When I say badgered, what I mean is if you look at the Fortune magazine, the TechCrunches today, when they talk about AI, right, you think of that as all of AI, but in fact, it's what I call digital AI. And this is something I actually took a long time to discover, even though I was fully steeped in it. 5 years ago, I was a fully digital guy for all my life, right? It was after the acquisition by Panasonic that I realized there is something else, that the kinds of AI, the digital in digital processing, digital out, cannot solve, or cannot solve effectively, cannot solve cheaply, or cannot solve in a finite amount of time. So it's in a way, through no significant fault of their own, the GEs, the IBMs, and so on, basically got killed by Darth Vader, simply because, of the wrong approach. So I can stop here and just say, okay, that's why you're not crazy, okay? So I alluded to the fact that we were acquired, or we, meaning my previous team, was acquired by Panasonic, back in 2016. We closed the transaction in 2017. And that's when, for myself, I began my latest hero's journey. Because initially, I applied everything that we knew, that we were expert at. The call to action for us after the acquisition was we were the bright, shining thing, right? And then it was implementation of AI, go around the global company and sprinkle a little AI onto this product and that. And we very quickly failed, right? And it wasn't just, getting used to the process and so on. This is, we failed technically, okay? I'll tell you about the story of that failure, right? The call to action here, Princess Leia, which is represented by 200 different projects within Panasonic, a big one, and the one that keeps coming up, and then that was very profitable, very strategic to the company. Some of you may know that Panasonic is actually no longer a significant part of the business is not consumer electronics anymore. It's very much automotive, avionics, manufacturing, robotics. If you drive Teslas, all of those batteries are actually made by Panasonic, not a single one made by anybody else, right? The packaging and so on, the battery management system is done by the Tesla team. So predictive maintenance. This is a precise formulation of the problem of predictive maintenance, which is, if you translate it to a data science or an AI problem, you're trying to predict the probability that a particular piece of equipment will fail within some specified amount of time. And then given that information, you would say, okay, well, I'm going to stack rank it, 80%, 70%, whatever above that, I'm going to go and preemptively replace that compressor. Right, and if you talk about oil and gas, right, it's not just food spoiling, but millions of dollars per hour, right, 50,000 barrels a day, if you have something fail. So it's not the cost of the equipment necessarily, but the cost of having to shut down. So you want to prevent this. That's the call to action. How many people have seen, whether you have done it yourself, which we did initially, being sitting here, or have seen other people in industry saying, well, this is how I do predictive maintenance, anomaly detection. Show of hands. Right. In fact, it is 99% today, right, of the responses. So what is anomaly detection? Anomaly detection answers a different question from the one I just asked. It says, does anything look different today, this moment? Does anything look different from the past? So, for example, you see these peaks here, right? Out of that, the human eye can look at that and say, oh yeah, that looks anomalous. And we can build algorithms, right? Very effective algorithms today to detect these things, right? What we need is, of course, a lot of data from the last 3 months, the last 3 years, and then those algorithms begin to say, okay, now I sort of see what normal is, and if it's something different from that, I will alert you, okay? But if you stop there, you get killed by Darth Vader, right? As it was told to me internally, okay, I'll tell you this, right? Essentially, our internal customers at Panasonic effectively told me, Christopher, this is worse than nothing. Okay, it's not just, this is worth less, this is worse than nothing. And the reason it's worse than nothing is because this is not actionable. We created an additional workflow to the regular maintenance process, and yet we're not telling people, go fix that compressor. So something's different. Now it's your problem. It's like, please don't tell me those things anymore, right? Because that may be somebody simply shutting the plant down, right? Apart from just like regular false positive of machine learning, different doesn't mean bad. And different is not actionable in terms of replace the compressor or the filter, right, or something else. So in fact, I'm here to tell you it's worse than nothing. And if you've implemented that and you face these difficult conversations, as Nanda and I have, you're not crazy, okay? So that's where we were. Fault prediction, on the other hand, is more than just anomaly detection, right? The upper half that you see, anomaly detection, you have unspecific anomalies, and then, well, okay, I guess the Amber Alert, right? then some human expert has to figure out, okay, what do I do with this? And in fact, that is what we implemented. And I'm sure that resonates with many of you who have implemented predictive maintenance using sort of digital machine learning anomaly detection. You have to sort of hand those signals over to some human domain expert, and then they will diagnose that. And they say, oh, don't worry about that. Or that one, okay, you got to send a truck out. What you really want is an automated system that goes all the way through and say, I'm telling you that this compressor is likely to fail with 80% chance over the next 30 days. That's what you want. But that's not what we delivered in the first 6 months of being part of Panasonic. Why? Because as Ving and I struggled, we kept asking, I need enough failure labels. That's how I work. That's how Google works. That's how Twitter works. That's how Facebook works. Don't you know? I've taught this stuff, right? Give me enough labels and I will tell you anything. That's how Silicon Valley today operates. Give enough data, I give you God, right? But the real world isn't like that. The physical world, right? You can't generate 1 million clicks and say, okay, then with that, I'm going to optimize for advertising revenues. You have to say, out of 3 or 4 failures a year, build a system that will predict similar failure. And by the time you stratify that by the model year, by the location of operation, by the workload, you basically have maybe 1 failure in the last couple of years. It's just impossible to do what we call traditional machine learning. Right? I'm going to call it digital machine learning. So don't blame GEs and IBMs of the world for being stupid. They're very smart people, right? It's just misled by our own expectations. Whereas when we say, let's get Seguchi-san's knowledge, domain knowledge, expertise about fault, and then automate it into an AI ML system, right? That idea alone is extremely powerful, right? And if I just end the talk here, and that's what you've been doing, that's why you're not crazy. Okay. The question, though, is can we do that efficiently, right? Can we do that profitably without having to hand code it, right? Write Python code and do all of that in Boolean logic. So in order to do that, right? So we kind of almost the end of the movie, no? Right? Luke Skywalker, after the realization, still doesn't have his lightsaber. Okay? So we need one more thing. Okay? Creativity is the intersection of 2 things that were previously unrelated, right? So what is that one more thing? What is our lightsaber? Well, I'm going to shift gears and spend a couple of minutes on something that have come to the public perception just very recently, right? How many people have heard of, and I know these are terms that are still being coined, like for example, generative AI, right? Or foundational models, right? These are essentially training very large models. Large simply means lots of data, so that somehow there's a base model that understands something about the world. And it's, just once that was made available, and I predict over the next 5 years, there's going to be a whole bunch of startups doing really interesting things with this. Bunch of them are going to fail, but a few are going to be awesome. Right? So I'll give you a few examples. I know you've seen a lot of these things, but this is just the set, because I myself, a lot of times, like, we're in the field and we know all this, and that way see how some of these toys, really, some of these tools are being created. It's actually quite amazing. So this one is text to 3D actual model. So you can actually type, a person punches in manner consistent with martial art, right, and other things. And so I'm going to click through here and show you the video. This is on Twitter, by the way. Right? Person turns to his right and paces back and forth. Right? This was not possible just 1 year ago. Okay, so of course we all know what's happening behind the scenes, but that's sort of my life with technology. I always know what's happening. When I see it, I'm still amazed. It's like a magic trick being performed, right? This was not possible a year ago. Okay, I'll give you another example. Okay, so let's say we're in this room and we want to do remote meeting. Of course, we're used to having 2 or 3 cameras. Is it possible to have just 2 cameras and see us from every angle? Well, if you have a model that understands the concept of this room, it's kind of like in your brain, you can sort of see us from above, right? Well, that's happening. So these are a couple of people with a camera. Just sit and wait. That was generated. That is entirely generated. So who would expect that the 3D meeting in the future is not a bunch of cameras, it's just 2 cameras, and then the rest is just generated using models, right? And there's a whole bunch more, maybe one more I'll show you. This is pure text. This is to help you write a thoughtful article, right? So you can type in some text, it'll extract the keyword, that's easy. It'll summarize it, and then it's also helping you find counter arguments, so you can write a thoughtful essay all by yourself, right? So many of my friends hate it if I use the word understanding, because to them, the bar is higher than that. But whatever is the model behind it is there's a measure of understanding of the world that's able to generate these things. Okay, so I'll probably share the thread. There's a long thread by someone that collected all these things. I just love it. There's music generation. There's one that says, give me a music loop of Lennon and John Lennon smoking weed together, and something comes out. I say, well, that would be Lennon and Lennon smoking weed together. Okay. So the question here is, what if we apply foundational models or generative AI or sort of this model understanding to industrial AI, right? Might we be able to do that codification, that conversion of human knowledge into AI models in a fully or somewhat automated manner? Certainly not requiring a bunch of data scientists and programmers to code it in Boolean logic, okay? So that's what young Skywalker needs. And I'm going to ask my colleague Roshan to show you an example of some of the tools that we're building to make that happen. Go ahead.
All right.
You do that as well. Go ahead.
Oh, okay. I thought he was going to do this, but well, so if you have that knowledge, you know how to tell when you're going to have a refrigerant leakage, or you know how to tell when you're going to have when the condenser is not clean in your refrigerator. You can just go over here and record and say, well, I have 3 showcases, and I need to look at their temperatures, and if all of those temperatures are too high, say above 7.5 degrees Celsius, then I need to look at the evaporation pressure, or I need to look at the condensing pressure. And if both of those are too high, then it's a refrigerant leakage. If both of those are low, then I'm looking at the condenser not being clean. And
I noticed it was recording that the whole time.
Yeah, and I can keep going, take all my knowledge on how to diagnose refrigerators, from all of my several days of experience. And this will just take that information, put it all down, and we can delete this beginning part. Don't need that.
Okay, so that's just a transcription.
And then I can go over here and hit translate, and it'll take that knowledge, and it'll turn it into a nice, simple, organized format that I can look at.
We just went from unstructured to structured, essentially. So there's
Right.
a DSL, there's a domain-specific language that is translated into.
Right. So this takes the things I've said, it tells me, I can look at this and say, all right, these are the features that I implied by what I said. These are some rules that I came out with. And in the end, those rules lead to a set of conclusions. And from that, I can go straight into building my model, give it a name. Okay, Oracle Model 1. Using this untitled knowledge that I just created and a data set that I cheated and uploaded beforehand. And I can just hit build model.
So there's a combination of that knowledge with the data set that you have. Now, this is the data set that I say there are not enough labels, right, to train on using traditional machine learning.
And there, it's also a pretty small data set. This happened very fast. But I already have a model that is ready to go. It's ready to put into an application, right? There's an API you can use to access that model and put it directly into production. In fact, we can see right over here doing just that, where we put that model through some evaluation, and we see how well it did.
Excellent. I need to move along, but this is excellent. Thank you, Roshan. So you can see that, right? So that's both magic, and then also showing you the trick behind the magic. So I hope that is interesting, because when I show them a magic trick to people and I explain to people, they say, oh, okay. But imagine, okay, forget about everything between. We went from what Roshan was saying to an operationalized model. Okay. All right. So continuing or wrapping up my and our team's story, right? You all know fear leads to anger, anger leads to hate, hate leads to suffering. Now, I thought about how did we succeed where others were struggling or even failed. We were quite lucky, right? I don't think this would have been possible, this insight, this struggle, we could have overcome it if we had not been inside as a full-fledged member of the Panasonic family. Because if you're a vendor, there are limits to what the level of patience, the level of information sharing that people will share. But being part of Panasonic allowed us to try and fail and try again and fail and say, let's do this this other way. So it's the moral that I learned from this is trust can lead to insight. Insight leads to solutions, and now, being an independent company again, solution can lead to success, these tooling platform. So our path to success is sort of the summary, right, of the approach. One is to translate domain knowledge into some structured form. We kind of take a very complex problem, even impossible problem, you decompose it into simple steps or simpler steps, then it becomes tractable. Second step is that now that you have the structured form, in our case, we define the DSL, right? The minimum necessary, but no less, and create models with various target architectures. And I'm not going to go into all of that. I think there's going to be a talk, sometime during the next couple of days that will go into in depth in some of those actual architectures that show you the combination of knowledge and data working hand in hand. Okay, but then you generate effectively a machine learning model, right? That will benefit from more data coming in the future. So you can start with 0 or some, and then sort of smoothly move into more data-driven as you get more of that. But you can get to market, 6 months versus 6 years. And the third step is use these models, because at the end, it is a predictive model, right? It's a black box. You can build intelligent systems with these models. So these are sort of the steps 1, 2, and 3. I want to close with some thoughts this way. Again, referring to Mark Andreessen, because he's sort of my favorite example of his transition from software eating the world, and then during the pandemic, he published something on, with Andreessen Horowitz called "It's Time to Build," and he was lamenting the fact that how many people have come across that article? Right? It's an excellent problem statement. It doesn't have a solution, but it has an excellent problem statement, which is why is it that in the most advanced country of the world, right? At least we believe we've always been there, and we're still there. Why is it that our response to the pandemic so terrible? And it's not just a sort of subjective statement. If you look at, the availability of hazmat suits, the masks, and so on, right? Like all these things have to be made somewhere else and bought and imported into the United States. So, and infrastructure, various things, crumbling and it's so old and so on. So there's a call to action. So it's time to build. Okay. And he identified a problem that has to do with politics, but I think the problem transcends politics. I think the problem is, right, that we've decided that the US is going to be on that software layer and the rest of the world would be the making of things. Well, the good thing is that trend is reversing, right? For geopolitics, political reasons, whatever it is, but it is a good thing overall. Whether you agree with the politics, but long term, it's going to be good for the US because these are life critical systems, right? And so there's going to be a lot of investments coming in, coming back. The near-term markets and everything, the gyrations, many of us have portfolios that have suffered significantly, but I'm very confident over the next 5 years, all of this is going to usher in a new era, right, of I don't want to use the word prosperity, but possibilities, right? Green infrastructure, renewable energy, and so on. These logos that I've selected are companies that are investing heavily in the US, right? Panasonic, there's a new $4.5 billion EV plant. That is not just for Tesla, right? That is in Kansas. I don't know whether you track this information. LG, the same thing. TSMC, right, is now building the world's most advanced semiconductor plants in Phoenix, Arizona, and so on, Intel. So I have a flashback, right? So tomorrow we're going to be at Stanford, right? And it was mentioned that's where this was the year of my PhD. So I'm much older than some of you that are sitting here. I'm not sure if you were born there yet. But there were 2 artifacts that I created during that time. And the left-hand side is a very long title. That was my PhD thesis. You can see I'm a very atomic guy, all the way down to the not just transistor level, but electron level. That was my full-time job. My advisor, Simon Wong, that's what he believed I was working on. But in fact, as most good graduate students do, I was really working on something else on the side, right? So I was always late to the meetings. I didn't know why. But I was a hacker. I was fascinated. I've been hacking since I was 13, right? So what I was really doing is there was this thing, coming out. It was called Unicode, right? And I was already writing a bunch of software to standardize Vietnamese and so on. It seems significant today, but you have to go back there. Vietnam was completely an insignificant country. The Vietnamese American community was also insignificant. So it was really a hobby, right? But as a result, Vietnamese was included. I won't go to complex reasons why it's not that simple into Unicode in sort of full pre-composed form. My point here is that the work that I thought was my main work, and I was going to get famous and maybe not rich, I didn't really care about it at the time, but was my PhD, and I was sort of doing this thing on the side. But now, 30 years later, looking back, nobody knows or cares about the left-hand side, right? And then the impact that Unicode, or certainly Vietnamese and Unicode has had, is my life's work. So my point here is, you never really know. I don't want to quote Steve Jobs, but I think that's the closest, right? He says, you only see the dots looking backward. You cannot predict. But I've seen enough things start small and grow and be impactful, and I think that is this group here, right? The group that is not crazy, right? But that we've been failing and we've been trying to figure things out. My hope and my prediction is that over the next 5 years, knowledge-first AI, right, will be essentially, people, if we would succeed if people go back and say, well, of course that was obvious. What are you talking about? Right? Vietnamese and Unicode is obvious. What are you talking about? I didn't have time to explain to you why it wasn't obvious at the time. Okay? So that would be success when it becomes normal. Okay? It becomes normal to combine human knowledge with machine learning to succeed. But that's what you can do today, right? We can sort of run ahead of others who, believe it or not, if you buy into what I'm saying, completely be aware that there are a huge swathes, certainly in Silicon Valley, of people who say, no, give me more data, I'll solve anything, right? But we're practical people, we have to get to market. So join us in this knowledge-first revolution. Thank you.
Thank you. You talked about basically what becomes the Darth Vader, what are the things that can make things fail. And I thought this was really interesting, and I like this idea that in the next 5 years, things that may seem odd now will seem normal, and that's success. What do you think are some of the specific barriers in the very near term, and how should those be overcome?
So everybody can hear the question, correct? The one that I come back time and time again, and you probably know, I talk to a bunch of friends, investors and others. So James Cham is one of my close buddies, and he's one of the general partners at Bloomberg Beta. One thing he said to me that I remember right after the acquisition, we had lunch, and he said, Christopher, you're going to be one of the smartest guy in industrial AI in a couple of years. Like, come on. But the second thing that James sort of had a long conversation with me about was, like, all the ideas that I shared with you were not like a moment that it came out, right? So I was sharing my pains, my sorrows, and my challenges, and so on, right? And then I said, we have to do something different. And like, there's not enough data. right? The first thing that I said is there's not enough data. I remember there was a meeting I had at CES with the CEO of Panasonic, Tsuga-san, and he was keeping close tabs on these projects. And I have to credit him. He said, yeah, I hear that you're succeeding in some and not so many others. And then he said to me, Christopher-san, right? This is the Japanese terms of because at the time we were still talking about got to collect data, big data, and all that. And he said, Christopher-san, I think, we can't be Google. We're not as good as Google. That's what he said, because we don't have a big data problem. We have a small data problem, right? And then it took me days to fully appreciate, that abstract perspective. And then I started talking to James and others that we actually have a small data problem. And I'm about to answer your question. To a person, they all rejected that thesis as an opportunity. They said, well, you have a small data problem because you are behind. Eventually, you'll catch up, and you'll have big data. So I think that's the biggest barrier to that realization. There are data sets that you can sensorize the entire system, and you can collect it for 50 years. The data, the information, the knowledge that you need to solve that problem is not in that data. So that's what we mean by small data problem. It's not that the size is small. It's too small. It doesn't have the necessary intelligence. Meanwhile, there's knowledge, human knowledge already there. So, and then again, when you talk about that, people would say, oh, you mean expert systems? We try that. So I would summarize it as the answer to the question, all the problems, all the barriers are cultural, not technical, right? I can tell you stories about why, for example, NoSQL is a crazy, wrong name. I'm going to waste your time with that. But the entire industry, like 1 million people can be wrong. You're not crazy. Yeah, thank you.
We have time for one more question.
Thank you. Great presentation. The compression was on point. I'm actually working with compression right now in my company. How does your team account for the fact that oftentimes human-based knowledge can sometimes be just as wrong as it is correct, and work with that?
Yeah. So the question is, knowledge can be wrong or correct. I've come across this a lot. In fact, we're working on one use case where we're combining 150,000 domain experts. And these are fishermen, so you wonder how do you, because usually domain expertise is only 2 or 3 people. That's a dominant problem. So when we combine that, there's going to be a lot of conflict, a lot of and the way I think about that is that it's the same thing as if you have 2 data rows that conflict with each other, right? So there will emerge a sort of a body of common knowledge, right? And then that will then be sort of the general bias of that data set. As far as I'm concerned, knowledge is the equivalent of data. And then you would, so the way we deal with, for example, how do you deal with fish identification in Hokkaido versus Okinawa? And that's where the specific knowledge that may seem to be conflicting, but in fact it is, Hokkaido is way up there and that Okinawa is way down here. Then we would have, quite frankly, 2 different models, right? But they all benefit from the general body of knowledge, and then things that are specific to Okinawa and things that are specific to Hokkaido. That's how we deal with it. But the general way I think about that, because we've come across this a lot, is that it's not significantly different from data rows that conflict with each other.
Thank you. Mike Cross from Beyond Limits. So I just want to ask, very cool demo, by the way. And
Thank you.
Predictive maintenance is a great place to start with that. How would the system handle other situations where you have many nested layers of knowledge, like a knowledge tree, or other applications like in the medical area where you have ambiguous knowledge? Could you maybe just describe how you might do that?
Yeah, knowledge, hierarchical knowledge, and then ambiguous knowledge, right? In a way, ambiguous is similar to conflicting, right? So that's how we would handle it. And by the way, we have not solved all of these things, right? This is not a system that has addressed all those things. So in terms of hierarchical knowledge, that's not something we have built. But if you mean hierarchical in terms of diagnosis, right? Do this, and then this, and then this. So that we have built something like that in terms of fault prediction. So we go through the heuristics of an expert. We sit down with them, and then they say, well, just like what Roshan earlier just showed a single decision, but we can actually incorporate a decision tree, right? So if this, then this, and so on. And that's not special to, say, machine learning. We just build that as a process, as opposed to a single model. Okay.
All right, great. Thanks, Dr. Nguyen.
All right.
And for
Thank you.
any other questions, please I'm sure you'll catch him somewhere around over the next couple of days.